Hello, this is Mike Lively, and this is the second video on tips for building 3D games for the web. And last time we talked about the good news of 3D game programming for the web for Flash developers, that things are getting faster and easier to do. And we went over a number of tips on how to make things faster and better on the web for your games. And today we're going to specifically concentrate on images. We're going to talk about optimizing your images for the web, the designer and developer war that goes on there. We're going to use a little bit of Photoshop, some 101 there. I'm going to tell you avoid transparency if possible. Talk about what bitmapping means. We're going to talk about the viewport and what I call the 1/3, 2/3 rule. And then, not part of images, but of course important for optimization is to always count vertices. You'll find that in many of these development packages such as 3ds Max or Cinema 4D, you actually have the ability to turn on a vertice count. And they'll tell you as you make your models if your vertice count is high or low, and you want to always optimize that, bring those vertices down as low as possible, and yet keep a high quality model. So let's get started. Oh, the designer war. At Northern Kentucky University, I had the opportunity to train a number of designers to become programmers, and always, especially those who come from a rigorous design background, they are not counting pixels. They are used to designing for print. So they actually want their pixels really high. They want to look really beautiful. But when you try to put that on the web, guess what? It's a catastrophe. So let me tell you one of those catastrophe stories. On my desktop there's an image of my family. I'm going to bring that into Photoshop. So I'm going to right-click on it, and I'm going to just open with Photoshop. And you have to be very careful about images, especially when you're dealing with people who are not aware of how to optimize them for the web. I once had a designer build this beautiful website in Flex, and they had put the image of an instructor right in the front, and it looked beautiful. And the image was only about 100 by 100 pixels, and the website ran so slow, and so I had to troubleshoot that site and figure out what was going on, and I couldn't figure out anything except I kept looking at that image. And when I opened up the image, that image was actually megapixels in size. It was huge. And so what the designer had not done was actually optimize that picture, bring it down in size. So let me show you how to bring a picture down in size. And many people think if they're an application like Photoshop or another imaging processor in Word, if they just shrink the image of the application, they've made it smaller. They haven't. It's still the same pixel size, and it still takes all that processor speed to optimize it. So you have to actually bring it into an image processing application like Photoshop or Fireworks and bring it down lower. And this is how you do it. Just go to Image. Just go to Image Size. And say I just want about 100 by 100. So I can keep my constraints and just put in 100. And there you go. It shrunk my image. And now I want to export this for the web. So I'll just go to File. So now I want to export this for the web. So just go to File. Go to Save for Web and Devices. And up here in the corner you have a number of options you can choose from. JPEG, PNG. For just images alone with no transparency, you want to go with the JPEG. That's going to give you the highest compression rate. So this particular image doesn't have any transparency. We'll go with a JPEG. Let's go on down here and take a look at what else we get from this application. This application down here at the bottom actually going to show us how large our image is and also how long it takes it to load. Isn't that nice? And once you're done optimizing your image for the web, you just come along here at the bottom and you save it. And that's all there is to optimizing image for the web. And I actually have done a lot of work with this in different applications, and applications like Fireworks, for example, you can really get down to the nitty-gritty. Just keep in mind, if you're a developer working with a designer, there's this designer-developer war. Many designers have been trained to develop for print, not for the web. And so you got to be aware and make sure that they're optimizing their images for the web. Another thing you want to highly avoid when you're working with images in a 3D application are transparencies, if possible. Transparencies really lug your processor, and you can immediately see the drain when you start putting a lot of them in. Let me show you an example of a game I built wrongly, but actually had a nice visual effect. In chapter 10 of my book, I talk about building games, and in this particular game right here is that I've created a jiglet bounding box, but the box itself is transparent. So I actually put a little bit of a kind of a shading here to make it look like there is a box, and there's glass, and these balls are in this glass box. And that's a nice, beautiful effect, but the problem with this box is transparent, and it really lugs the processor to actually work with a transparent box like this. So if you can avoid transparency, I actually would redo this game and not use this transparent box if I was looking for a little bit more speed. But if you're looking for beauty, sometimes there's a trade-off. But beware, transparency is going to really, really, really hit your processor hard when dealing with 3D objects. Okay, the next thing I want to talk about, of course, are bitmapping. Bitmapping can make a big deal when you are working with lots of images. So what is bitmapping? Bitmapping means you need to have your images at factors of 2, 4 in size, 8, 16, 32, 128, 512, It could go on to 1024, whatever, as long as they're a factor 2. And they can be rectangular as well, so you can have a 256 by 512. It doesn't matter. Because inside your processor, there's these internal filters built in. When they see a 512 by 256, for example, they know how to handle that and more efficiently than an odd-side image. Is this always possible? No. But when you're dealing with lots of images and you do this optimization, you'll see the difference. And let me show you an example. Let's go back to Photoshop. So in Photoshop, this image is not optimized for the web. So if I had one, hey, that's okay. But if I got 100 images just like this, I better use that optimization, that mip mapping. So let's go ahead and mip map this image. See, it's an odd size. So I'm going to actually go to Canvas, Image, Canvas size, and I'll change this to pixels. And you can see it's not mip mapped, so let's make it 256 by 256. I hit OK. And sometimes you just can't do this, but in this particular instant it worked. I have a 256 by 256. However, I got a little bit of a white border here. I could actually put something around that, or I could actually bevel it. Let's go down to my layers. Go Windows, Layers, and I'll bring up my effects. I'll just go ahead and bevel that. So let's bring up the effects and hit a bevel. I just move it around a little bit. You get a little bit of a bevel, but you get the idea of what I'm talking about. You can actually bevel this and actually take advantage of that little bit of an edge or corner you got there to actually make your image look dynamic. Okay, now we've talked about avoiding transparency. We've talked about mip map. We want to talk about reducing viewport size. And I think a great way to look at this is to go back to chapter 2 of the book, which we've been going through in our series. And so in chapter 2 of the book, we actually talked about viewport. So what's a viewport? Well, a viewport displays the rendered scene. It's a sprite or a rectangular region that is painted with a snapshot of all the stuff that contained in the frustum. So if we go back and take a look at the frustum, we actually have this 3D scene. And so all our objects in a sense are being moved around mathematically, and that's the 1/3, 2/3 rule. So in the mathematical background, all these objects are being moved around and worked with. That's 1/3 of your processor time. But to paint those to the screen, that's 2/3 of your processor resources. So remember, painting onto the screen on a viewport is 2/3 of all the processing that you need to do. And in that process, you're really eating up CPU. So the smaller you can make that viewport, the more efficiently you can make your painting. And now we're going to take a look at Bowling for Buddies and show you how that works out. Bowling for Buddies is a wonderful game, and it's totally optimized for the web. Now, in a lot of paper vision applications, you can actually turn them on. Your computer actually get hot. You can hear it start to breathe because it's really using a lot of processor speed. That's not the case for this particular game. It's beautiful. Let's hit start. So I'm actually starting right here, and I want to talk about this game a little bit. You would think that the entire viewport is this entire screen right here, but that's not what's being rendered. Actually, if you look at this, this is the images that are not being used at all. So you're not wasting all that rendering time. All that's really actually being done is you've got your tiny little viewport right here. That's it. That's all the space that's being rendered to the screen. Let me show you that real quick. So I'm going to grab this ball. You see? I can't go any further than that. And I can't go over here. You see? This is the only small area, and then once I get there, the ball is taken away from me. I can't go any further than that. So that whole viewport region that's being rendered to the screen is just right there. It's not even bigger than that. So they're really, in a sense, saving a lot of processor by not rendering this entire screen. Now once that's gone, okay, let's let that ball go, boom, it switches scenes. Woohoo! So actually what's being done here, once again, the viewport rendering range is only right here. It's not any bigger than that. So it's a beautifully optimized game where they're really watching that 1/3, 2/3 rule. So if you can reduce your viewport size, you'll get a huge savings in the amount of processor that you have to use. I want to make one more point as far as vertice size are concerned. Look at how they model these pins. These are really low in polygon number. And so they lost a little bit of a visual effect there, but who cares? It's a fun game. The ball's big enough in its rendering to look good all the way. They brought that polygon count down. And they had to. And let's play the game one more time. And the reason they had to do that, look at this real quick. These balls are fairly complex. And so if you come along here and you try to model them, you're putting a lot of polygons in there. And that's just too much processor speed. So they did the trade-off. They did the visual trade-off. They brought their polygon count down. And you know, who cares? It's a fantastic game. And you know what they get away with? Listen to the sound. Let me tell you, every time when it comes to working with visual effects, sound is more important than eyeball. And so if you can combine that sound, those pins being knocked down, with a low polygon number, then you got something that feels real. And that's what it's all about on the web. Hey, this was Mike Lively. Hey, thanks for listening, and have fun bowling for buddies. See you next time.